Okay, chemistry and pre-AP, this is part 6 of the thermo notes. So we just talked about the phase diagram, and now we're going to talk about phase change diagram. Similar but different. A phase diagram is talking about temperature and pressure and how they relate and how the phases change. And this one, we're specifically in a phase change diagram, we're specifically looking at temperature and energy. And so how energy is making these things change, which is a little bit more familiar to you. And this is the one you should pay more attention to, especially if you want to take AP. AP exam does ask questions about this, so it's important to kind of understand what's going on. So a phase change diagram is showing you the transition. And so as temperature increases, and as we increase energy, those states change. If you look, we don't have anything that has a really low energy and a low temperature. So I said that wrong. I was pointing at high energy. We don't have anything that has a low energy and high temperature, right? And so it's kind of trying to help you understand what's going on with those phase changes. During a state change, temperature does not change because the energy that is added is used to separate the particles from each other. So I'm going to kind of explain this. So as we start out at a low temperature, we have a solid. And as I explained in one of the previous videos, in Antarctica, that ice is not necessarily 0 degrees Celsius. It could very well be a lot colder than 0 degrees Celsius, and it is, honestly, or else it wouldn't be so cold in Antarctica. And so this 0 degrees Celsius is where we transition from melting to from liquids. So this would be essentially, if this was a water diagram, which I just drew this one, this would be 0 degrees Celsius. That means everything below this is the solid that exists. It's ice that exists, but it's colder than 0 degrees Celsius. When I hit that 0 degrees Celsius mark, or 32 degrees Fahrenheit, that's when it starts to melt. Or in our case, in Texas, that's when we finally think things are starting to freeze, because we never see that. But that being said, and during this time, we have melting and freezing. So the previous statement I just said, where it says, during a state change, this is a state change, I'm changing from a solid to a liquid during this phase, okay? Temperature does not change. If you notice, it's a straight line, we didn't go up, because the energy that is added, all this energy we're adding in here, is used to separate the particles from each other. So think about ice. Ice is all packed together. All the particles are cold, and they're all packed together. And so that energy that we have is separating them to give them that extra motion. So it's used to break them apart, to break down, to overcome those intermolecular forces that have been holding them together in that solid. And so that's why we have added energy but no temperature change. And whenever finally all of it has changed from a solid to a liquid, then when we add that energy, then we start to see the temperature change again, because now we're just heating that substance. And so then here we have liquids that exist. So all of your slanted lines are your phases, either your solid, your liquid, or your gas. All your straight lines are that phase change. And so here we'd have our phase change. Now I have liquids going to gases. Again, we have to break apart those molecules. That liquid has to separate even further into a gas. And so I also have color coordinated for you endo and exothermic processes. Again, so if I'm going from a solid to a liquid, that means I'm going this way. I'm going up the ladder and then I go over. I am melting that solid into a liquid, and then I go up, and then I'm vaporizing that liquid into a gas. Those are endothermic processes. Heat is absorbed. Energy is absorbed. And then as I go backwards, condensation and then freezing, that's exothermic. Heat is released. Okay, so hopefully that starts to help you understand this diagram. If you have questions, please let me know. And then we're gonna start specific heat. So you can watch these. You can also look up other videos. You can send me remind messages. We can Zoom together and further explain this for you. So far, no math has been involved, but we're about to start getting into some math.